Hello everybody, this is Mr. Navarrete, and today I'll be going over the combined gas laws homework. And while they are only a few problems, some of them are going to be a little tricky, so let's get to them. For number one, it says, find the original pressure of a gas if its original volume was 32.6 centimeters cubed at a temperature of 14 degrees Celsius, but has a volume of 57.1 centimeters at standard temperature and pressure. First thing I'm going to do is write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. Now, a few things to note. We are given our temperature at 14 degrees Celsius, so I need to convert that to Kelvin. Also, we're not given our P2 or T2. All we are told is that we are at standard temperature and pressure. Knowing that, I can say my T2 is going to be 273 degrees Kelvin, and my P2 is going to be 1 atmosphere. I can change that depending on what units I'm given. So now I'm going to plug everything in. And now I see that I need to solve for P1. Isolating P1, I get P1 is equal to 1 atmosphere times 57.1 centimeters cubed over 273 Kelvin times 287 Kelvin divided by 32.6 centimeters. And I get a original pressure of 1.84 atmospheres. All I did here was substitute 1 atmosphere for my P2 and 273 Kelvin for my T2, since we are working in standard temperature and pressure. For number 2, it says, find the original volume of a gas now occupying 224 milliliters at standard temperature and pressure if its original pressure was 98.0 kilopascals at 7.43 degrees Celsius. First thing I'm going to do, write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. And again, a few things to note. We are given our temperature in Celsius. I need to change that to Kelvin. We are told we are now occupying this volume at standard temperature and pressure. So standard temperature is going to be 273 degrees Kelvin. And for pressure, before I used 1 atmosphere, but we're not working with atmospheres. We're working with kilopascals. So instead, I'm going to substitute standard pressure with my units for kilopascals. Plugging all of that in, I added my pressure with kilopascals and my temperature in Kelvin. Solving for V1, I get 101.325 kilopascals times 224 milliliters over 273 Kelvin times 280 Kelvin divided by 98.0 kilopascals. All of that into my calculator, I get an original volume of 238 milliliters. Again, always make sure that your units match. If this is in Celsius, make sure that it's in Kelvin. And if your pressure is in standard temperature and pressure and you're working in kilopascals, then just substitute for kilopascals. No need to go to atmospheres. For the next one, it says, find the original temperature of a gas now at standard temperature and pressure if its pressure was 765.4 millimeters of mercury, and if the volume changed from 25.2 centimeters cubed to 634 centimeters cubed. First thing I'm going to do is write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. A few things to note. We are told that we're at standard temperature and pressure, and we are working in millimeters of mercury. So, plugging everything in, only things that I added were the 760 millimeters of mercury because we're at standard temperature and pressure. Both of my pressures are in mercury, millimeters of mercury, so I'm just going to keep it like that. And for my temperature, I was told standard temperature, so that's 273 Kelvin. Solving for T1, I get 765.4 millimeters of mercury times 25.2 centimeters cubed times 273 Kelvin over 760 millimeters of mercury times 639 centimeters cubed. All of that into my calculator, I get a temperature of 10.9 Kelvin. And again, make sure that your units match. Make your life easier. For number 4, it says, find the volume a gas would have at standard temperature and pressure if it occupied a volume of 456 centimeters cubed at a pressure of 754 kilopascals and a temperature of 800 degrees Celsius. So first thing I'm going to do is write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. And plug everything in. My original temperature was 800 degrees Celsius. I need to change that to Kelvin. My pressure is in kilopascals and I am in standard temperature and pressure, so I'm going to use kilopascals as well. And again, because we are in standard temperature and pressure, my second temperature is going to be 273 degrees Kelvin. So plugging all of that in and using the proper units, I see that I need to solve for V2. And studying V2, I get 754 kilopascals times 456 centimeters cubed over 1073 Kelvin times 273 Kelvin over 101.325 kilopascals. Plugging all that into my calculator, I get a V2 of 863 centimeters cubed. 5 asks, find the pressure a gas would have if it was collected at a pressure of 104 kilopascals and its temperature was changed from 14 degrees Celsius to 97.3 degrees Celsius, and its volume changed from 25.4 centimeters cubed to 936 centimeters cubed. Same thing as always, going to write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. We are not told we're working at standard temperature and pressure, but instead we're giving all of our values. We're given our volumes. We're given our pressure. The only thing to change here is our temperatures. We need to make sure that they are in Kelvin. So plugging all of that in, I see that I need to solve for P2, isolating P2, and plugging all of that into my calculator, I get a final pressure of 3.64 kilopascals. Last one says find the temperature a gas would have if it was collected at 18.6 degrees Celsius and its volume was changed from 963 centimeters cubed to 461 centimeters cubed, and the pressure changed from 783 kilopascals to 12.0 kilopascals. First thing I'm going to do is write down my equation. P1 times V1 over T1 is equal to P2 times V2 over T2. We're not told we're working in standard temperature and pressure, and instead we're given all of our values. Only thing here that I need to change is my temperature. Make sure that it's in Kelvin. Plugging all of that in, I see that I need to solve for T2. Isolating T2 and plugging all of that into my calculator, I get a final temperature of 2.14 Kelvin. And that's it. If you have any questions, make sure to message myself or Mr. Morgan on Schoology. Other than that, stay safe and I'll catch you all on the next one.